Let's talk about factoring. So in this video, you can see what we're going to do here. We'll talk about regular factoring, where you have a quadratic and the leading coefficient is 1. And then we'll talk about factoring by grouping after that. All right, so let's start with this first example here, x squared plus 7x plus 12. So if we want to factor this, that means we want to write it in the form x plus something times x plus something. So we want to pick two numbers for these spots that multiply to the 12 and add to the 7. So two numbers that multiply to positive 12 and add to positive 7. In this case, it's going to be 3 and 4. So 3 times 4 gives me 12, and then 3 plus 4 gives me 7. So in these spots, I'll say plus 3 and plus 4. It doesn't matter which spot the 3 is in or the 4, so you could have the 4 here and the 3 there. Either way, this is a perfectly factored version of this quadratic. All right, a similar process for this next quadratic here. So again, I'm going to have x plus something, or minus something if it's a negative number we pick. So I want two numbers that multiply to negative 10 and add to 9 because of the positions they're in this quadratic. In this case, that's going to be plus 10 negative, or minus 1 rather. So plus 10 minus 1. These will multiply to negative 10 and they add to positive 9. So again, it doesn't matter which one goes in which spot, but I'll have a plus 10 and a minus 1 in the spots. All right, so this is how we'll always factor a quadratic. So you have an x squared, an x term, and a constant term. But where the leading coefficient, so the number on x squared is 1, so it's essentially just not written like this. When you have a number that's not 1 in front of the x squared, this type of factoring doesn't exactly work. So you have to come at it with a different strategy. There are a couple of different strategies to do this. So if you have something else that works for you, that's cool. What I typically do is called factor by grouping. All right, so you can see my two examples here. We'll start with this first one. So instead of just looking straight at the negative 4 to get started, what I'm going to do is multiply the 6 right here and this negative 4. All right, so 6 times negative 4 is negative 24. So when I'm picking two numbers in this moment, I need them to multiply to this and add to the 5. So I need this to be a times b, and then 5 to be a plus b. Okay, so these numbers are a little bit bigger than what we were dealing with before. So let's think about the types of numbers that could multiply to 24. So we have 2 and 12. We have 3 and 8, 4 and 6, and we could also do 24 and 1 if we needed to. All right, so because it's a negative 24, one of these numbers has to be positive and one negative. And I would say the 3 and the 8 are my winner. I can do negative 3 and positive 8. So these will multiply to negative 24, and then they add to this positive 5. All right, so with factor by grouping, once I make this decision, I'm not quite done yet, the way that we just kind of were done in one step up here. What we're going to do with these two numbers is break up this middle term, this 5x. Instead of saying plus 5x, I'm going to say plus 8x minus 3x, or the other order, minus 3x plus 8x. It doesn't matter which order you pick. All right, so I'm going to restate 6x squared. And why don't we use the numbers exactly in the order that I wrote them here? So we'll do minus 3x plus 8x. And then I'll keep the minus 4 that was there. So this is still equal to what we originally had, but now we've strategically split up that middle term into two pieces. Right, so once we do that, we do the grouping part of factor by grouping. So I'm going to take my first two terms here and factor out of them as much as I can. And then same thing here, take my third and fourth terms, factor out of them as much as I can. All right, so between 6x squared and 3x, I can take out a 3 and an x. So what's left in 6x squared is 2x. And what's left in negative 3x is just the negative 1. So really, I'm dividing out 3x. So 3x divided by the 3x I took out cancels to 1. Between the 8x and the negative 4, I can pull out a 4. 8x with the 4 divided out is 2x. And then 4 with the 4 divided out is just 1. So in this step, once we've factored out what we can, what we hope and expect to see is that in both set of parentheses, we have the exact same thing. So see, I have 2x minus 1 here and here. That should always happen. That's kind of part of this whole strategy here. So I'm going to factor 2x minus 1 out of this whole term and out of this whole term. So I have 2x minus 1. And then what's left in all of this, once 2x minus 1 is divided out, is just this 3x. And then this term here, when I pull out 2x minus 1, has only this 4 left. So we have the factor 2x minus 1 that was in common. And then what was left over is the 3x and the plus 4 that make the other factor bubble. Remember that you can always FOIL this back out to double check that your answer was right. If you multiply these together and simplify, you should end up back where you started. All right, let's do one more example of factor by grouping. I have negative 2x squared plus 13x minus 15. So I need to compute negative 2 times negative 15, my first and last coefficients, that's 30. So I'm looking for two numbers that multiply to 30 and add to 13. So I'm going to pick 3 and 10. 3 times 10 is 30, and then 3 plus 10 is 13. So I'm going to use those to break up this 13x, this middle term. Okay, so the negative 2x squared stays the same. Instead of 13x, I'm going to say plus 3x plus 10x, or the opposite order. It works out either way. It doesn't really matter. So those are the same as 13x. And then I'll keep that minus 15 at the end. And then same as before, you take your first two terms and factor out what you can. For this one, I have a choice to make. Why don't we for now, like with the minus sign, I mean, why don't we for now just pull out x and see what happens? So this with the x factored out is negative 2x. And then 3x with the x divided out is just 3. Between 10x and 15, I can pull out a 5. And I get 5 divided out of the 10x is 2x. 5 divided out of 15 will have minus 3. And I have a problem here, and this happens somewhat frequently. So what we're expecting is to have the same thing in both parentheses, but I don't have that right now. There's a 2x and a 3, but the signs are like opposite. This is minus and plus, this is plus and minus. So that means out of one of these, I just need to pull the minus sign out to the outside. So I can make this a negative x, or I can make this a negative 5. It doesn't matter which one you pick. I'll pick the first one. All right, so write this as a new line. If I pull out the minus sign as well, now the signs of those terms inside flip because the minus sign was pulled out. And now what's in the parentheses perfectly matches, so I can end this the way that the other one did. So 2x minus 3 is the factor that they both have. And then what's left over is minus x plus 5. All right, so the last thing I'll mention in this video is just quickly what you do if what you're asked to factor is not a quadratic. So all of these were a degree 2 polynomial, which is a quadratic. If the degree is higher than 2, like what you're seeing here, we're not going to go all the way to the extreme case of factoring. So in this class, like if it's a degree higher than 2, you're going to be missing some of the lower power terms at the end here. So see how neither of these have a plain number term. So all that we'll worry about is pulling out the highest power of x we can, and then just using our quadratics knowledge. So in this first one, each term here has at least two x's in it, right? So I can factor out an x squared and knock down the power. So x to the fourth with x squared divided out is x squared. 2x cubed with x squared divided out is just 2x. And then finally, this last piece loses the whole x squared and we get -8. Now I can just use regular factoring to factor what's in the parentheses. So the x squared carries down. X squared plus 2x minus 8 is x plus 4, x minus 2. So now this is the fully factored form of this degree 4 polynomial. Let's do one more. So we have 2x cubed minus 24x squared plus 72x. So the highest power of x we could pull out is just x because this one is so low. But notice that all three of these coefficients are even numbers. So I can actually pull out a 2x to kind of bring these numbers down a little bit. 2x cubed with 2x divided out leaves x squared. 24x squared with 2x factored out. The 24 goes down to a 12, and then we have one fewer x's. And then finally, 72x divided by 2x will give me 36. And again, now I can just carry the 2x down and worry about factoring the quadratic thing in the parentheses. Right, so -6 and -6 will do it here. So we'll have x minus 6, x minus 6. You can keep it this way, or you could write this answer as 2x times x minus 6 squared, since that would be the same thing.